Dear students, we are studying the course instrumentation, and first chapter we are studying fundamentals of measurement. In fundamentals of measurement, we'll just revise what we have seen till date. We have seen the aims of measurement. Also, we have seen the basic measurement system, and also we have seen the static standards of measurement. In standards of measurement, we have seen the four type of standards: international standards, primary standards, and secondary standards, and working standards. And we are studying the static characteristics of measuring instrument. In static characteristics, we have studied accuracy, precision, sensitivity, linearity. Then we have to study the resolution, drift, and hysteresis. So let us today study these properties: resolution, drift, and hysteresis. So first consider the resolution. This is fifth static characteristics of an measuring instrument. In some instruments, the output increases in discrete steps or continuous increasing input, because there is no linearity in the output. Though there is given for a given input, continuous input you are giving, but output increases not in linear way, it increases in terms of steps. Like over here, you can see, if you give the input as shown in this figure, see, this is the input, and input increases continuously in linear way. But if you see the output will increasing in steps, like steps over here. So what will happen? It may be because of finite graduation in the meter scale, or the instrument has a digital display. As a result, the input indication changes discretely. Means, if you are having a digital display, for example, if you are measuring a voltage and you have given the voltage, and your display has a resolution in perfect digits only. Perfect digits means you can either measure 1 volt, 2 volt, 3 volt, 4 volt, but your reading might be in between 1 or 2 volt. If it is 1.5 volt, it cannot measure, because your display having the capacity to read out as either 1 volt or 2 volt. Means a 3.5 digit voltmeter. Suppose I will take 3.5 digit voltmeter. The operating in 0 to 2 range can have maximum reading of 1.999 volt, and it cannot measure any change in the voltage below 0.001 volt. So you cannot go below this. So resolution indicates minimum change in the input variable that is detectable in the output. For example, if you take 8-bit analog to digital converter, you have to convert continuous analog signal into digital. It is 8-bit. So what you have to find with 5 volt input? You have given 5 volt input. How you can, what will be minimum, measure the minimum voltage? That is your input, which is 5 volt upon 2 raised to 8, means 8 bit minus 1, that is 19.6 millivolt will be act as a resolution in that case. Okay, so resolution is what? The resolution is also defined in terms of percentage. So resolution is delta I, is change delta I upon I max minus I minimum into 100. The quotient between measuring range and resolution is often expressed as dynamic range, and it is defined as dynamic range is equal to measurement range upon resolution, and is expressed in terms of decibel. The dynamic range of an n-bit analog to digital converter comes out to be approximately 6n decibels. Okay. This is the resolution of an instrument. Then next characteristics, static characteristic, drift. Drift is the variation in the output of an instrument from desired value for a given input due to change in the sensitivity and interfering inputs like temperature change, component instability, etc. For example, consider the strain gauge used in balance bridge without using compensating strain gauge as shown in the figure. The input-output characteristics of instrument when ambient temperature changes after calibration. You can see that this is transfer curve output and this is EI, which is input. So what will happen? This is your sensitivity drift, and this is actual operating curve, and this is the calibration curve. So how much they will change? That is your total error. That is zero drift from origin. How much it is shifted? This much zero drift plus sensitivity. How much sensitivity? This is sensitivity. So zero drift plus sensitivity, you get the actual operating temperature. That is when you are measuring change ambient temperature. Change causes the change in resistance and strain gauge. This result in the bridge circuit becoming balanced, and the consequence of this, there is an output at zero, which correspond to zero drift of an instrument. Means if the environmental condition changes during the measurement, there is always change in the measurement, and that refers to that corresponds to the zero drift of an instrument. The resistance change also affects the sensitivity of an instrument, which results in the change of the slope of the input-output curve as shown in the figure. Therefore, total error in the vault due to drift is combined effect of zero drift and sensitivity drift, and then last characteristics is hysteresis. What is hysteresis? Hysteresis exists not only in magnetic circuits but in instruments also. For example, the deflection of the diaphragm type pressure gauge may be different for the same pressure, but one for increasing and other for decreasing as shown in figure. The hysteresis is expressed as a maximum hysteresis as a full scale reading, that is referring to hysteresis H is equal to O max, it is minimum, maximum minus O minimum into 100. You can see the transfer character, this is output characteristic, this is input, and if you see at hysteresis you are going like this, you are increasing, but if you stop input and there is decreasing like this, means if you go like this is arrow given over here, it is going like this and again coming towards zero like this. So this is from the hysteresis curve. So how much hysteresis you are getting? At 50%, whatever maximum here you are getting, that is H. Okay, and O max, maximum output you are getting at a given input, minus O minimum, that is initial. So H upon O max minus O minimum into 100, which is nothing but hysteresis error. Okay, so these are the three characteristics remaining static characteristics of measuring system. Thank you.